My name is Joanna Smith. I'm so excited to be here with you. I am the founder of Daily Smith STEM, an organization that helps students excel in science, technology, engineering, and math in an exciting and fun way. We teach students how to code using Python, and they code using Python to code music, rather. We also teach them mathematics through roller skating, and they also learn how to skate and design their own skates. And then, last but not least, we learn negotiation and mathematics. So, I just want to talk about 3 ways to take the pain out of math. 3 ways to take the pain out of math. Okay. Now, you may be asking, why is this important? This is important because a lot of the times where we are, students are afraid of mathematics, they're not excelling in the subjects, and so what happens is they think it's not for them. So, here's what we can do. And the first thing is to relate math to something that's meaningful. And today we're going to be talking about relating math to music. So, did you know that measuring and reading rhythm in music is very important? It's very mathematical, right? So, for the most part, what we have is fundamental components of music, and one major fundamental component is rhythm. Okay, rhythm, one and two and three and four. And now I remember when I was younger, we were all in drum corps together, a lot of us, maybe about 20 or so, and we'd all come together. Somebody had to play the bass, somebody played the snare, somebody played the hard top snare, some played the toms, I played the trios. And so, what was exciting about it was that we all had to learn rhythm, right? We also had to learn how we were actually putting things together together as a whole in different parts. So the parts that made up the whole, right? So I played trio, and usually I only had 3 drums, right? On my thing, it was kind of like trios are like a subset of a tom. Um, but what I did was I had to play um, flam taps, right? And so it sounded like this: flam tap, flam tap, flam tap. So one and two and three and four and, right? Or one E and a two E and a three E and a four E and a. And so what that does is it separates the patterns, okay, into pulses or beats at specific intervals of time that allow your song to sound as a melody, right? Because if I was singing forever and I didn't have any timing, right, things would be a little difficult. And so things would be completely opposite to how we would go about doing this particular thing. Now, um, but the important part about that is to recognize that when we talk about timing, there are principles, mathematical principles behind these patterns that can literally speak to the time signature, which tells you how many beats are in a specific measure. Or so each time you play the song, if there are 4 beats in the measure, you're gonna hear one, two, three, four. Or there might be a variation, and I think that's what's also awesome about music and mathematics. It's like there are variations, right? So like you can do a addition problem that has a variation as a subtraction problem, and then you can do that as a division problem as a variation as a multiplication problem, right? So in music we do variations, and so I have variation of a 4/4 timing, which means there are 4 beats in a measure, right? One, two, three, four. We may have a variation of that same timing in 3/4 timing, which means that we'll count it as one, two, three, okay? Or 2/4 timing, which would be one, two. All right. So what's exciting about that is that we can measure each beat with a count, and each note actually has a number attached to it. Right. So that's one. So just thinking about the rhythm as being mathematical. The second thing is the musical timbre of a note. Did you know that each note has a certain sound? And each note also has a sound. When I say that's in hertz, the measurement of sound, well, at least one. But the measurement of that can speak to um, either the pitch of the song or the note. So if I play middle C, it sounds different than a C further up on the piano, like a C5 or C6. And you can hear that. If I play an A4 or A that is right next to middle C, right, I am actually hearing a pitch that's at 440 hertz. And if I continue to go higher on the piano, if I play that note again, 8 notes above, we're going to double that actual measurement of sound, and it will be now 880 instead of 440, right? And you continue to go up and up. And so you can see that there's a correlation between the number, the actual music note, and the pitch. Okay. So last but not least, we can talk about musical scales. Now, musical scales are really mathematical simply because when we start playing them, like, C, D, E, F, G, A, B, C, or Do, Re, Mi, Fa, Sol, La, Ti, Do, right? Those notes also incorporate numbers to them. So, usually, what you're going to see on the piano, when people play a scale, they're playing 8 notes, okay? 8 notes in a scale. I'm thinking about a major scale as of right now, not pentatonic or whatever, but there are 8 notes in a scale, in a major scale. And so when we're playing that, it's also called an octave. Okay. And so what happens is I can play, and once again, it's a variation. There are 12 major keys. So I can literally play this set of 8 notes in 12 different ways. Okay, and that's just on the basic level. So when I'm playing that, say I play C, C is my one, D is my two, E is my three, F is my four, the G is my five, my six is A, and the seven is B, and then the C is a eight, okay, or the octave, or some people go back to the one. Now, that's relative depending on if you want to, play 16ths or 13ths or whichever. But for our purposes, we're going back to the one, or we can also call it an eight. All right. So we can see that musical scales are also mathematical, and as you continue to learn them, it takes the pain out of mathematics. It becomes more fun, exciting, even though you are still speaking to a discipline factor, but it may not be as rigid. All right. Just want to share that with you. I hope you gained some knowledge on today. You can find me at Daily, Daily Smith, SMITH, Inc., Inc.com. And I look forward to seeing you at our upcoming listening party where I'll be releasing some new music for my 32nd birthday. And we will also be advocating and speaking about science, technology, engineering, and mathematics there as well. So I look forward to seeing you in person. Bye.